away we can go. All right. So with your subject, I don't know. I think the subject outline. I'm on here as a student. So as a student, I see pretty much what you see. So it's pretty important to grab this and make sure that you're following along, because this is what it's going to be all about. Okay, so this is like your go-to document, if you like. Okay, so we're kind of in this space here, so they're going to be a little bit of vectors. Now what I'll do is I will enunciate some of what I think is important in those spaces, but essentially I've got to get through the things that I promised to get through, which were the 6 things. Okay, so just a reminder, there's other people that have joined us now, so I'll just make them aware. Welcome you guys that have come along. I'm Jason, so I'll be here every week, and basically what my intention is to make sure that you guys have got the fundamentals that you need. And if you go onto the Maths Study website and click on the MRS link, you'll see these things. Now, I've been through those 4 things already as of last week, so I'm going to revisit a little bit on quadratics because it has some attachment to what happens in vectors, or it crops up. Some of the geometry, algebra geometry, comes up. If you want that stuff there, I've posted something in the modules. So if we look at the modules now, I'm just seeing what you see as a student, and that was last week's contribution. Okay. Alright, so yeah, your tutorials are a great place to go to. You've got a good group of tutors, so hopefully you'll spend time there as well, and rely on that to help you. Seems like some basic stuff, but as I showed last week, it's inculcated in your knowledge of what happens in this subject, and so if you don't have these, this is more than likely the thing that's causing you problems. So we're going to have a look at that now. So I'm going to start off with functions and their graphs and talk specifically about E and Ln. So this is just a very informal way. If you've got questions, by all means pipe up. There's no stupid questions, as it were. You can say, you know, whatever you like in that sense, in terms of asking a question. Alright, so E and Ln. So E and Ln, and Ln as inverses. Okay, so the way that I do this is that coming out of school, it tends to be a lot of confusion in students about this whole business. So there's a calculus idea, and then there's a mathematics idea, and these two are intimately linked here in the maths idea. So what's important to recognize is that if you have y is equal to e to the x, the graph of y equals e to the x is, we know, looks like this. It's got this big swoop that goes up, and anything raised to the power 0, which we did last time, is 1. Okay, so this is a fundamental and foundational graph that needs to be well understood. And the idea here is that last week we looked at linears, and with linears what we found was that a linear, now what's the equation of that one? What's the equation of this straight line?
Y equals to x.
Yeah, y equals x. So, and it's got that form, y equals 1x plus 0 y-intercept and gradient m. So this fundamental information is information that I go over that people need to understand. Now, if we were to ink this up, now you might have done this in class already. I certainly do it with my students. I ink, all right, ink, just being frivolous and funny in a dad kind of way, and then fold the page over, crease it over. What you find is that you get each of the points being transferred. Okay, now who can tell me what that is? What have I just demonstrated there? What's that an example of?
It's a flip. I don't know.
Yeah. Okay. So here
the inverse of, I guess.
Okay. So there's a couple of ideas there. It's very, very important, and it's just you're just about to hit a subject where the concept of what I asked you is the thing that needs to be known. So anytime we do a reflection in the y-axis, in the y equals x, now there's lots of other reflections that you can do, and in fact that's going to be an important part of this subject, and we'll learn about reflections in other topics. Mary will take you through those. What you get is an inverse. Now this idea of an inverse frightens students to death. It's like, oh goodness, an inverse. But what is it in effect? What I want to do is attach a maths idea to it, and every time we think of undo, we think of an inverse. So for example, in year 8 you would have got some 3-step equations, and it might have been something like actually what I'll do is I'll just get rid of the y. And you would have been asked to solve that. And so what's the operator joining the joining the 2 and the 6x? The operator is minus. What's the undo of minus? Plus.
Addition.
So yep. What you do to one side, you do to the other. So straight away this becomes a pretty easy problem. What's the operator between the 6 and the x?
Multiplication.
This all leads somewhere, people, okay? It's not just me playing silly buggers with year 8 work. This all leads somewhere that's quite important. So that's right, it's multiplication. So how do you undo multiplication?
Divide.
Right, so what you do to one side, you do to the other. Okay? So what you've been doing for a number of years is you have actually been doing undo. It's just that you might not have thought of that in terms of inverses and functions. So what we've got to recognise here is that this reflection is the ln of x. Now the ln of x is the log base e to the x. So these two are inverses because they reflect in this line, and it's the most important relationship that you can have, and it's the least understood. Okay, so when you come to do calculus with this, it's very, very confronting. Alright, so let's do another example of undo, just as a side light. So if I've got y equals the square root of x, how do I undo the square root? So I take the square.
Square it. Yep.
And what's the maths of that? The maths of that is x to the half. And this is very important. It comes up very soon in your tests. When you see it in that form, what do you do with the indices?
Multiply.
Across the bracket, you multiply them. So a half times 2 is simply 1. It becomes 2 over 2, doesn't it? Which is another form of 1. So this becomes 1, so in effect you've removed the square root. So this is a more complicated example of undo, which you'll need as you go forward. Alright, let's say we've got y equals e to the x. How do we get to x? How do we get to x? Okay, how do we get to x? Well, what's the operation? The operation is exponential, isn't it? So then you ask the question, how do we undo exponential? And here it is. How do we undo exponential? We take the log. Okay? So we take the log to both sides. Okay, there it is, right in front of your face. First mastery test coming up. This is going to be there. Maybe. Or in the second one. I don't know. One of them. Okay, but what's the point of this? The point is, let's look at this, and do you recognise that is undo? If that was undo, the result was you were expecting to see brackets and indices disappear. the result of undo is that you expect those to disappear. Okay, now for some reason that 3 lines there evaporates when you come from school. I don't know why, but not everybody gets that. Some do, and some invariably don't, and you need that. Okay, so let's say that we've got y equals the ln of x. Okay, y equals the ln of x. So what's the operator on x? The operator on x is?
Multiplication.
No, it's the function ln.
Oh, okay, yeah.
It's the function ln. So how do we undo ln?
You use an exponential.
Easy peasy.
E.
Okay, so we undo ln by taking e to the y. Now, if you've ever read the textbook version of this, whatever textbook you had in stage 6 in the high school, it makes you want to vomit. It's so convoluted, you know, the power raised to the nth root or whatever it is. It's terrible. It's hideous. You can't read it. But this is like, okay, this is the bit that explains. Now, expectation. Where's our expectation? Our expectation is this bit here is undo. So now we've got this thing here is just equal to x. So this is the profound relationship that exists between e and ln as a mathematics idea. This is the most important. It's the second most important thing you come out of high school with. The next most important one is the one we'll do in a little while, okay, in exact values trig. So what you'll find, people, is that as you come and sit with me and we go through this, you might find after an hour or two your head starts banging, okay? And it's not that I do it a hard way that requires you to think, because I'm like the long way teacher, right? So I'm going to fill in all the blanks, but it's a lot. It gets to be a lot. So if you experience that, don't panic, just let me know. And you can re-watch the video, and because I am recording these now, because you're coming along, so I want you to be able to scrub back over it. The videos themselves, probably the best thing to do is to come here and ask questions. All right, I tend not to want to do the videos for these sessions because it's laziness, it promotes laziness, but hopefully you'll see the merit, and I know at least one of you has seen the merit in these sessions already this week past. Alright, so let's just think about e to the ln. I'll do an example of e to the ln and why this is so important a bit later on, but I want to just show you something else. Now, ln is log to the base e. So if we, if we do it this way, if we say y equals not ln of x, not y equals the log to base e of x, okay, but let's do y equals log base 7 to the x. So what's the operator? And now this is where the concept comes out, okay? What's the operator on x? The operator on x is log base 7. Right, log base 7. Okay. How do we undo? In other words, what's the inverse? What's the inverse? So if this one was e, for lns we took e's. Now e's just a number, isn't it? If you get your calculator and you put e in, it's just a number. Okay? So it's one of those, we're going to get to the profound nature of that number later on, but it's just a number. So instead of taking 2.7s, I said take e's, right? To undo ln, you take e's. In other words, I could have said you take 2.71s. Take 2.71. So what are we going to take here to undo log base 7? If that was log base e, and we took e's to undo it, if this is log base 7, how are we going to undo it? We will take
7s.
7s. Genius. Okay, so what this does is we raise the exponent, okay, and the expectation is that you recognise that is undo. So 7 to the y is equal to x. We've now isolated x. Okay, so it doesn't matter which way you go. You can write y equals 7 to the x. How do I get to the x? The exponent is 7. 7 to the x. How do I get to x? How do I undo?
Use log.
Log base 7. So this can be done with any expression. Okay? And this is the undo. So that's the power of the concept, is that we have the expectation now. We'll just have the 7. So there's other little things about log laws and stuff that will crop up which you may ask me about, but these are the essential elements of undo when it comes to inverse, because this is a maths idea. What's the relationship between undo and ln? So one of the things that will come up later in the course, and I don't expect you to know how to do this, but if you've done any level of maths at high school you may have seen this, is if I have something like dn dt equals kt, okay, or yeah, something like that, maybe n kt or something like that. This says the proportion or the rate of change, and we'll do these later in the course, is proportional to some constant. And if I make that an n, I'm just going to modify that now. If I make that an n, this particular example says that I'm going to say that the rate of growth of the population number, n's in this population, is proportional to the actual number. So the reading of the equation becomes important. Proportional would look like this. Actually, I want to switch that around. My bad. So it's proportional to n. That's how you would say that in a less sophisticated way. Okay. Now sometimes you can get these where it's 1 over n. It's inversely proportional, and so on and so forth. Okay. But for our purposes here, what's the significance of what we're doing about this maths idea? Well, if you've done any kind of things, we separate the variables, and I want to show you this now because you'll remember it. When it comes up, you'll remember it, and you'll go, oh, I recognise that. And the whole purpose of my know-hows with you is that you learn to recognise business. Okay, expectation and recognition are the key players in your maths education here. So what we're going to do is separate the variables. So I'll have dn over n, so that's bringing that n down, and then I'll put the dt up, cross multiply, so dt by dt by dt, and then so I'll have this. So what this means is I've got 1 over n dn equals k dt. Okay, so I've separated the variables. Okay, so if I integrate these, now I don't care if you know how to do the integration, okay, because the results of the integration we'll go over later. If you don't know how to do that now, that's okay. But the 1 over n, if we integrate 1 over n, what's that going to be? Now, this is where I'm going to start to help you guys in a most profound way. Now, some of my colleagues won't love me for doing this. Okay, because there's a thing called Mathematica, and Mathematica has a free web page that you can go to called Wolfram Alpha. If you've never seen this before, you can thank me later. Okay, because there ain't nothing you're going to do that can't be checked on here. So that's what I'm advocating. I'm not saying I want you to be calculator people, because we basically should be able to get through the course without a calculator. But what we want to be able to do is verify, don't we? We need like a Jason or a Mary. We need like a Jason or a Mary. That's really what we need. So we can check that. If that's completely oblivious to do, we can... Now, what have I done there? Have I done a mistake? Let's just check that. dn... maybe it should be the same. That'd help, wouldn't it? I might change that one. Should be... Now, what have we got? Okay, so when we integrate 1 over n, we get the log of n. Now that'll be a natural logarithm. Okay, so it'll be the ln of n. So it's a way of checking Mathematica. So hopefully over the course of this term, you'll get to use Mathematica more from aside from all the other stuff you do. So what this will tell us is that we get the ln of n plus c. And what happens with this one? We conjure t, so we'll get kt plus c. Now I'm just going to put the c's over. That's one of those frustrating things that happens, you know, when you do that. So I'm just going to call that kt plus big C. Okay. Now the problem we're getting to is here's an example that uses this mathematical idea of undo. So how do I get to the n? How do I get to find out what the population is? Well, it's ln of n. So what have I got to do? I've got to
use e.
I've got to take ln. So this seems to be the big one in this course that throws students. So here's the ln of n. E to the kt comes up plus this big C. We recognize this as undo. Ta-da! We got it. We got the n. Now what do we do with these guys? You may remember that when we had a2 times a3, we did all the a's last week, and I somewhat said, oh, that's just a to the 5, and I said the important thing is we're going to have a2 plus 3, and then we're going to go backwards. Okay, so we've got an a, 1a, there it is, with a plus at the index, and then we've got 2 a's. So the expectation here is that you now generate 2 e's. There it is. You're generating 2 e's. One of them will have the kt, and one of them will have the c. Now the convention is that this remains a constant, and it's usually the constant a. Now I'm not teaching you differential equations. I'm teaching you where ln and indices come in. That's the purpose of this work. Okay, so we've invoked the inverse rule to do undo, and we've used indices that university way. You'd be amazed how many students don't see this when they encounter it. Okay, so it's a bit of a big deal. All right, so the next thing then is we've seen the value in undo. We've seen the value in lots of different places, and that's just a maths idea. Okay, so what I'm going to do is just very quickly stop my video. So that's one video, and it's a bit easier to work in smaller chunks with videos, so I'm going to press, and I'm doing it locally here, I'm not doing it as part of the